The title of my presentation is Role of Curcumin in Metabolic Syndrome. Curcumin is not the only natural products I work. I work several other natural products, but this presentation is mainly entailed with curcumin. As this audience is very familiar, what is curcumin? Curcumin is a curry spice, yellow curry spice we found in any Asian home. And we have been using this in medicine several years. It's a rhizome or root of the turmeric tree. It's a polyphenol, and it's been like we have been using this medicine several years without knowing its biological importance. So if you look at the literature, it has been reported with several potential activities such as anti-cancer, anti-inflammatory, antioxidant. The topic of this presentation is slightly different today. So we want to look effect of curcumin in general under the lens of metabolic syndrome. So we want to know what is metabolic syndrome. Metabolic syndrome is cluster of interconnected conditions that significantly increase the risk of developing chronic disease such as heart failure, type 2 diabetes, stroke. It is a growing public health concern, particularly in developed and developing nations due to its association with obesity, sedentary lifestyle, and poor dietary habits. The prevalence of being overweight, type 2 diabetes, and metabolic syndrome has dramatically increased several decades. Consequently, the prevention and treatment is critical to curtail, increase the number of morbidity and mortality. Development of obesity is characterized by the growth of adipose tissue. As you can see, the blood vessels, curcumin, and obesity, or I would say in general, metabolic syndrome. Obesity come under the umbrella of metabolic syndrome. This work is done at Tufts University and part of it conducted at Joslin Diabetes Center. If you look at the curcumin, curcumin is a yellow curry spice. We use in Indo-Pak, it's used every day in the food. It's golden spice for health. It has been reported with several biological effects such as anti-cancer, antioxidant, so on. Today, I would like to look at this effect of this compound on obesity or metabolic syndrome. If we want to know what is metabolic syndrome, a metabolic syndrome is a cluster of interconnected conditions that significantly increase the risk of developing chronic diseases such as heart disease, stroke, type 2 diabetes. It's a growing public concern, particularly in developed and developing nations. If you look at the obesity is the development of obesity is characterized by the growth of adipose tissue mass. Like growing tumor, growth and expansion of adipose tissue require the formation of new blood vessels or angiogenesis. Angiogenesis is a growth of blood vessels, right? And there's one strategy to improve or to inhibit the obesity. We can cut down the blood vessels formation in it. So using that hypothesis, we study different mechanisms, how we can cut down the growth of adipose tissue, what are the ways we can improve. And in this study, we use the curcumin, a polyphenol from turmeric that inhibit the angiogenesis, decrease the differentiation of pre-adipocyte to mature adipocyte. And that's all I'm going to show you in these slides. To start to investigate the effect of curcumin on angiogenesis, we use the Matrigel. Matrigel is a gel where we seeded the endothelial cells. As soon as we see the endothelial cells, we saw the network of the blood vessels, or we can say we saw artificial blood vessels. And then in other set of cells, what we did, we take the cells which were feed with a different adipokine packet. How did we collect these adipokine? We basically took the visceral fat, incubate overnight. After that, collect the supernatant and add the supernatant into the matrigels. And we saw the blood vessels formation become cluster. And then another set of cells, we did the same process. We took the adipokines, and then on top of adipokine, we added the curcumin or yellow curry spice. We saw as soon as we add the curcumin, the network got disrupted, which indicate that adipokine, as you saw, promote the in vitro angiogenesis. By addition of the curcumin, we saw disruption in network, which indicate, yes, curcumin has the ability to inhibit the angiogenesis. In order to further investigate these processes, what we did, we took the 3T3L1 fibroblast cells. These cells has capability to transform into adipocytes. So these cells were treated with serum, insulin, and dexamethasone. After incubating that, we noticed that the cells which treated with 5 micromolar, 10 micromolar, 20 micromolar has some decrease in the red droplet. What we basically did, we transformed pre-adipocyte to adipocyte. After generating these as adipocyte, we add the red color staining. And as you can see in these pictures, red droplet is indicating the blood vessels formation artificially. So we notice effect of curcumin dose dependently inhibit the effect of red color staining, which indicates the less adipocyte generation from 5 to 20 micromolar. Not only that, what we did, we took the mature adipocyte, right? We took the fibroblast, convert into pre-adipocyte. From pre-adipocyte, we convert into adipocytes. And after that, after preparing these adipocytes, we incubate curcumin for 24 hours. Again, the same fashion, 5, 10, 20 micromolar. And we saw dose-dependent effect. After incubating these cells with curcumin, we take it out, we stand with red staining. And as you can see in these pictures, let me turn on my computer. As you can see here, the red droplet, this is control. You can see a lot of red droplet, while if you look at the 5, 10, and 20, we saw dose-dependent effect, and we saw the less color staining in 20 micromolar. That was encouraging. So the next question is that what's going on, how these molecule is functioning, in how these molecules functioning, what is the molecular mechanism, why the red droplet is decreasing from 5 to 20 versus control. So in order to understand that question, what we did basically, we investigate several pathways. Here I would like to show you only one pathway, which is called lipid energy metabolism. We want to see what is the effect of curcumin on these. So what we did basically, we tried to look at the pathways. The main pathway I'm going to show here is AMPK pathway. AMPK is adenosine monophosphate kinases pathway. AMPK is a key metabolic regulator in inhibition of initiation of mitochondrial biogenesis or increasing the fatty acid oxidation through the suppression. So if you look at here, the yellow curcumin, as soon as we feed curcumin into the cells, what happened? This curcumin initiate the adenosine monophosphate kinases phosphorylation at 3-172 subunit. As soon as the phosphorylation get activated, it basically activate the acetyl carboxylase. And this acetyl carboxylase, as soon as it get activated, the melanyl-CoA, which is another marker, decrease. Decrease of melanyl-CoA result in increase of CPT1. CPT1 is basically the transcription factor, which result increase. And as soon as CPT1 get activated, fatty acyl-CoA regulate, which result in fatty acid oxidation and stop the esterification. This is like a very simplified version of what's going on in our body. In order to understand this in detail, we need to sit down and look at every single pathway, the protein level, the transcription level, the further steps to understand. We also look some downstream factors such as PPAR gamma, enhancer binding protein, so on. So what we did, we actually took the curcumin and look at in vitro and in vivo level. In vitro, we look at the 3T3L1 adipocyte, and in vivo, we look at into the C57 black mice, and I'm going to show you both in detail. So now, if we look at the effect of curcumin adenosine monophosphate, we saw at Western blot or protein level that curcumin dose-dependently increased the phosphorylation of PMPK. And then if you look at that, at 20 micromolar, we saw the significant difference. Similarly, we also measure the other pathways such as acetyl-CoA. Yes, acetyl-CoA phosphorylation also got activated. And these proteins measure through the Western blot analyses. We also did the ELISA, but here I'm showing you the Western blot and transcriptional data. Similarly, We tried to measure the CPT1, the protein we tried in ELISA was not working. So here the data is only for the mRNA level. mRNA level is significantly increased compared to control. And then we also look at the GPAT cholesterol protein. It was decreased. So the most important marker in this presentation was fatty acid oxidation. We use a label hydrogen, and we noticed that effect of curcumin is significantly result in increase the fatty acid oxidation. So that's what the ultimate goal when we reduce the body fat. What we do, we burn our calorie, we increase the fatty acid oxidation. So this is a similar pathway, what happened in our body when we do exercise or when we fast. So curcumin is behaving the equivalent. Another parameter of curcumin is being reported in literature as a appetite suppressor, which I'm not going to talk here, but it has a several functions. So in order to investigate the molecular mechanism in vivo, what we did, we investigate the effect in C57 black mice, and we use the high-fat diet-induced model. And we use a 500 milligram per kilogram of the protein, and we notice some significant changes. If you look at this body weight, after like 12 weeks, we notice, yes, curcumin has a significant difference in body weight, like the mice which are getting high-fat diet. If you look at the last line and the top line, right? Last line is the mice which is getting regular diet. The top line is indicating the mice which are taking high-fat diet. You can say McDonald's diet, right? And then the body weight is significantly different, cow versus high fat. But as soon as we feed the curcumin, we bring down the line or decrease the body weight. It's not exactly same as cow, but it's significantly different compared to the high fat mice, which was definitely encouraging. We want to look at what are the mechanisms. Is it the same mechanism in vitro what we are seeing, or is it something different? In order to explore that, we dissect the monkey. Oh, sorry, we finish the study and we collect the body part of the mice, every single. We want to look at wherever the obesity, like all different fats, visceral fat, subcutaneous fat, and several other part of the body. We also measure the liver weight. I'm going to show you step by step. Everything looks definitely different from high-fat mice versus high-fat mice treated with curcumin. It's not exactly equal to the chow mice, but it definitely improved. So if you look at here, if we compare, we saw, yes, adiposity is different. Adiposity in terms of body weight, we look at it showing the difference. Also, as I mentioned, we collect the different fat, visceral, paragonidal, and subcutaneous. It was difficult to do the staining in visceral fat, so data I'm going to show you here is a subcutaneous fat. Subcutaneous fat is the fat outside of the body of the mice. So it was very interesting finding when we dissect the liver, when we dissect this mice and we collect the liver. The liver weight was definitely different in high-fat mice compared to high-fat versus curcumin. When we stain them with H&E, hematoxylin eosin, as you can see, the middle picture is showing the high-fat diet. You can see the big, like a droplet. These droplets indicating the high fat or indicating that liver has steatosis. Liver has some fatty particle. It's a fatty liver. When these mice, similar mice, high-fat mice, treated with curcumin for 12 weeks, you can still see the tiny droplet of the fat, but definitely it improves. So it's nowadays when you go to the doctor, if you have your weight is high and your blood pressure is high, or doctor say your liver is getting fatty, so you have to work on it. So this is like a common indication. We notice in mice, yes, giving the curcumin is helping improving the liver steatosis. It's not 100%, but it definitely shows some significant difference when we compare control versus high-fat treated curcumin mice. I have shown you earlier in the slide that curcumin definitely inhibiting the blood vessels formation in adipose tissue. Similar concept was investigated in subcutaneous adipose tissue. So before understanding that, we would like to have a few lines about angiogenesis. Angiogenesis is a formation of the blood vessels. There are several parameters which play an important role. One of the parameters is VEGF. VEGF is a potential angiogenic factor which produced by growing tissue to stimulate angiogenesis in order to receive nutrient and oxygen as needed for growth. So what we did, we grind that tissue, measure the protein level and transcriptional level, and we noticed that the monkey fat, sorry, not monkey, sorry, right? Nowadays I'm working in monkey, that's why the monkey is coming from my mouth every second. In mice, we noticed that the mice which are having curcumins definitely has the less angiogenic factor in adipose tissue, which was encouraging. And when we stain these cells with FITC, as you can see, this green color is indicating the blood vessels formation, while blue is the DAPI nuclei staining. This is a control, this is a regular pattern. When mice treated with high-fat diet, you can see adipose tissue enriched with the blood vessels. As soon as we gave them a curcumin, we saw the disruption in a network, which is again indicating yes, curcumin is inhibiting the blood vessels formation or angiogenesis in subcutaneous adipose tissue. Again, we look at the same factor in adipose tissues. We try to look at the visceral fat, periconidal fat, subcutaneous fat. So if we look at the effect of curcumin in PMPK, which is adenosine monophosphate phosphorylation, if you look at here, it significantly increases in high-fat diet treated with curcumin. We also notice the phosphorylation of acetyl carboxylase, which is slightly also increases. And then we grind that tissue and then look at the different, basically the different gene expression level. We also notice some regulation, and these regulation or these changes were significantly different compared to the high-fat mice. Not only that, we also look the plasma, lipid, and glucose level. Mice were fed a high-fat diet supplemented with curcumin had a lower level of blood glucose, triglyceride, free fatty acid, cholesterol, and insulin compared with those of mice fed with high-fat diet. So we can summarize this study that dietary curcumin supplementation prevent obesity and associated metabolic complication through suppression of angiogenesis by decreasing the VEGF receptor, by increasing the catabolic activity, differentiation of pre-adipocyte to adipocyte. We also measure a couple other markers, apoptosis and tunnel staining. I did not show you the data here, but we also noticed the improvement in apoptosis of adipose tissue, and we noticed several energy, metabolic energy markers such as PMPK, PACC, fatty acid oxidation were upregulated by effect of curcumin. I would like to thank for your attention and also the organizing committee for this opportunity. Thank you, everyone.